Hello, everyone, and I'm really excited to give this talk, and I'm really excited to have HashiTalks actually for the second year. And as Karim said, it took a lot of efforts for us to kind of think about it, but then somehow it magically happened. So now we have this for the second year. So back to the talk. Let's think about what we normally have. We have an idea. We have an idea about something cool. Fine, what to do next? Typically, we start to think about what is the easiest thing. Like we start to talk about what kind of cloud provider we should use or what technologies we should use, because PHP is not so cool anymore, but serverless is cool. And I'm really glad to hear a talk by Marcos about serverless, because yes, in fact, it is cool things, but it's pretty hard to do in Terraform. That's why there are no Terraform modules. Well, infrastructure is everything what is needed to support computing requirements of an application. Let's agree to this one. And now I'd like to ask you, most of you probably know what is DDD, right? So you can think like, hey, this is domain-driven design. And no, that's not true. This is design, draw, and deploy. So my name is Anton, and as some of you have already experienced in YouTube chat, my daughter is now watching this talk as well, and I apologize that she's talking in advance, but that's how it is. Pretty much everyone in my home knows about Terraform to some degree. I'm AWS community hero, and I've been using Terraform since 2015. And I try to stay active in open source communities by contributing and by maintaining different projects like Terraform AWS modules and pre-commit Terraform. And I like to figure out what are actually best practices, because by the time when I started it, there were no best practices and people were doing crazy things all over, and sometimes they ended up with bad solutions. So if you have Twitter or GitHub, or if you want to connect on LinkedIn, please let me know. As you probably understand, it's pretty hard to earn on just open source. So that's why I provide different services like consulting, workshops, and trainings, and so on. So Terraform AWS modules started in September 2017, and so far there were more than 7 million downloads. When people start with the infrastructure and they think about setting up VPCs or auto-scaling groups and so on, they don't have to do this completely from the ground up, because there are well-established practices, and that's what we publish on Terraform AWS modules GitHub account. And thanks to these sponsors on GitHub, as well as many customers of mine who support me, we managed to close and resolve more than 1,000 of issues and pull requests during these 2 years. So if you'd like to join, you're welcome. It will not make a lot of time and efforts from you. So let's get back to design your AWS infrastructure. Well, when we start designing our AWS infrastructure, we normally go to documentation. We'll look into AWS well-architected framework, and we read a lot about different white papers, guides, and how to do different things, how to make this. So we will be definitely spending a lot of time, and we will be overwhelmed with the amount of information which we discover there. That's fine. Then we realize that, okay, we actually want to draw our AWS infrastructure. And right now, there are a lot of different tools which you can use online. Some of these tools you already know, but I will focus on Cloudcraft, which is one of the best way to draw AWS diagrams. And using this tool, you can actually connect different parts of your infrastructure, specify properties like instance type or some other properties which make sense to you. So this is typically where your cloud architect will spend their time, and they will visualize it. Well, it was easy, right? So we talked about design and we talked about drawing. That's fine. Okay, like 66% of job done, pretty much. Now, when we talk about how to deploy this infrastructure, there are so many options which is like right now we are at HashiTalks, so we definitely have to mention Terraform. But let's look into different flavors of infrastructure. So infrastructure as, and if you are into binary, then you probably know what kind of 101 shades of infrastructure. Infrastructure as PowerPoint, also known as ClickOps, right? You open AWS console, you click, 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 and then you have something what is at some point of time, probably in 2010, was reflecting infrastructure. That's why the file name is called infrastructure 2010, fixed, and it's PowerPoint, so it's definitely solid, it's verified, it's approved, everything is static. Great. Then you know that AWS CloudFormation or Azure Resource Manager has concept of JSON and YAML files. So infrastructure as JSON and YAML files, fine. Then we have infrastructure as configuration files, which is typically as Terraform. And another type of infrastructure is infrastructure as structured key values configuration files, which I like to call Terragram. And then we have infrastructure as code, which is used by Pulumi or AWS CDK. So in this talk, I'd like to focus on just these two things because I honestly believe that this is a way how we should proceed. So infrastructure as configuration files or infrastructure as structured key values configuration files. So Terraform and Terragram. Now let's look into what kind of requirements and preferences we would like to have for our infrastructure. So we definitely have to have it as code. Well, okay, we want to have it reproducible. We want to have all kind of automation possible. We definitely want to use active community and proven technologies and follow best practices and all these cool things. Well, that's a lot of things to think about. So what should we care about? Well, you can think about, for my infrastructure, it's really important that my solution is short. Okay, I want to be able to test my solution, so testability is a key. Well, I come from a general programming background, so I really want to use all this object-oriented programming paradigms and maybe a domain-specific language as well. So that's critical for me. And you can think about some other things as well. So think for a second and try to figure out what is actually important in your infrastructure as code. Fast forward, my solution and my approach is that simplicity, velocity, and maintainability are absolutely essential for everything what we do. We're not writing code for the sake of short file or smaller lines of code, or we're not writing infrastructure as code so that we can test it. No, actually, we are not writing it for that. It's good that we can test it, and yes, we have to aim for that. But I wouldn't prefer to pick up the tool where I can do just this tool, but my solution would look like a monster, and nobody can maintain it. So I started project with an idea that, okay, cloud architect already visualize and spend some time, and then someone has to put it into code. So that's where Modules TF has started. It is an open source project, and you can see generated infrastructure code on my repository Modules TF demo. It is open source and it is free, and it's available for all Cloudcraft users. So Cloudcraft is used for visualizing, and then I use Terraform AWS modules as building blocks of the infrastructure. And then we'll look into using Terraform to manage infrastructure as code, and Terragrant to just orchestrate these invocations and to be an orchestrator of Terraform configuration. So I want to make a demo and show how this actually works. So this is, yeah, should be able to see it. So this is where I go to Cloudcraft, I log in with free account, and I just visualize some of my infrastructure. So here I put Elastic Load Balancer, and I specify that I want to have it as a classic. I can use another type, for example. And I specified that this Elastic Load Balancer belongs to this security group, and this security group belongs to this VPC. I did exactly the same demonstration last time, and this is not the key point. That you can go to Cloudcraft, visualize whatever you want, and that's it. Of course, you can think about this infrastructure as something more complete, which looks like this, but it's a little bit harder to explain. So I will just go back to the smaller one. Okay, so I have created this infrastructure, and I specified different components, and I put S3 bucket for this demo as well. So what I have to do now is that I click export and click Terraform code export, and now this diagram will be exported as code. So now this blueprint is converted into zip archive. AWS Lambda function has been executed, and I can download this archive. I have already downloaded this one, so I can open it here. As you can see in this folder, HashiTalk 2020, there are some files here. And the infrastructure is described inside of HashiTalks 2020. And what you can see here is one region folder. That's because all infrastructure has been created in one region. Inside of that configuration folder, we see a lot of other folders. Usually one folder is for each object. So if we are talking about VPC, that's one folder, security group, and so on. If we look into what exactly is inside of these folders, we can look into, for example, an auto-scaling group. Okay, if we look into auto-scaling group, we see that this is typical code, which is using TerraGrant latest version. Latest means the one which has been released, I think, 2 or 3 days ago, because there are some features of that one. Okay, so here we are using Terraform AWS module of specific version. We specify some dependencies here, and we specify some inputs here. Obviously, none of this I have written myself. All of this information came from the visual diagram, which I visualized earlier on Cloudcraft CO website. That's why information about security group is used as a soft link here. This is feature of TerraGrant. Instead of hard coding values, I'm using just link here. And same for all other connection, like VPC, ID, and security groups are extracted from VPC and security group layers, respectively. So now let me go to the terminal and actually show how this is working. So if I look into tree structure one more time, we have infrastructure inside of one region, and then there are configuration files for it. Okay, let me see. Yes. Okay. Okay, so here we have configuration inside of HCL files. You may think that why there are no Terraform files at all. Well, that's a valid statement, because when you work with Terraform configuration, you often expect to see at least one Terraform files. In fact, when I'm using TerraGrant, I'm not writing any Terraform code as such. I'm only invoking Terraform modules and passing different inputs to modules. So here I have I have HashiTalks, and then I have EU West. So if you've been using TerraGrant before, you may have seen local bin TerraGrant, and then I can run apply all. What it means is that I want TerraGrant to create this infrastructure completely, and apply all will figure out what it means, and it will go in dependencies and create them in correct order. So now if I run TerraGrant apply all, you will see something what is pretty hard to understand, because code is very verbose. What I made a small function which actually simplify output. I know it's not the most important part to be proud of, but still it makes life and adoption of TerraGrant much easier. So now TerraGrant output is much, much smaller. It's still a lot of information for daily usage, but it's better than it was before. So TerraGrant function is here, and I think I tweeted already. So now when I say that, yes, I want to create infrastructure in EU West 1, I confirm it, and I have already specified my AWS credentials as environment variables, so I just confirm. Now it's job of TerraGrant to do the magic, go in all dependencies and create what is necessary. It will take not very long time, but it will take some time. So meanwhile, while it's executing here, let's look into what's going on or how the code itself is written. Some features of TerraGrant, like soft dependencies to outputs, are really essential, which means that we can use just TerraGrant natively without using different external tools. Something what I wrote earlier was hook in shell script and then Go tool, which updated this using annotations. Now this is not necessary. And another cool feature of TerraGrant is that inside of this values or inside of TerraGrant HCL, I can use any expressions of Terraform itself. For example, if I want to create infrastructure in VPC, I'm able to specify a list of all availability zones instead of hard coding them. So this is a very effective way to use some expressions of Terraform instead of hard coding values. So what this looks like is similar as if I would be writing something like EU West 1A, EU West 1 2B, and so on. I don't want to hard code this one because I want to go across all availability zones and so on. And same I do with CIDR subnet function to calculate CIDR ranges for different types of subnets. That's pretty much it inside of HCL. Another feature of TerraGrant, which I heavily use, this has been a pretty big pain point for me, is that I actually used to mix Terraform and TerraGrant files in one project, which I didn't like. Now, I think 2 days ago, this became possible so that I can make TerraGrant to generate files like this using generate block. And I can also generate remote state configuration.
Anton, could you zoom the terminal and the code a little bit? People on YouTube are having issues watching it because it's small.
Yeah, that's downside of having big screen, I know.
Thank you.
Sorry. Yeah, I think I'm actually done with the demo. As you can see, the infrastructure has been created. If I go to the terminal, I should be able to see this instance is just running, so it's initializing. That's it. Now to complete the cycle, I can go to Cloudcraft, and I can go to live. And if I scan my environment, I should be able to see this, these resources here now as security group, auto-scaling group, and instance itself. So I can put this instance here and remove the rest. Okay, so yeah, unfortunately that's bad to have big screen, I know. So let me go through some benefits of modules TF approach. So first is that it generates potentially ready-to-use configurations. And you may think like, hey, potentially is too bad, right? Yeah, because it's not always enough to know information which you specified on the visual diagram for Terraform to create meaningful infrastructure. So we still need to know much more information to make it really good to use. And yes, it is best suitable for bootstrapping because we just want to get really enforced standards. And I believe that any enforced standards as well as any opinion is better than no opinion. So in addition to that, a lot of batteries included, like I'm using Terraform AWS modules as well as TerraGrant and pre-commit Terraform already built in. It is entirely open source and free for all Cloudcraft users, and even for people who want to replace Cloudcraft, but let's say you want to generate infrastructure by describing your you want to generate infrastructure as code in TerraGrant by describing infrastructure as plain English. Yes, you can do this as well. Or you can get your CloudFormation template and convert it into TerraGrant as well. A lot of interesting challenges will be there, but it is doable. And yes, I'm also enforcing Terraform best practices and segregation of duties, where people who develop something are not necessarily people who are going to use it. Think about this as me who are developing Terraform AWS modules with the rest of community and people who are actually using those modules. We often speak quite different languages. So if you want to get into all kind of Terraform 0.12 features and you're excited about them, great, you're welcome to contribute to most of projects which we have in open source. But if you are just starting with Terraform, you don't really need to know too much in order to just use it and have some opinion decided for you. As a roadmap, I have a lot of things, of course, I mean, otherwise it would be a dead project if there would be any roadmap. So I want to propose and to validate infrastructure drawing, whether this makes sense or not. Because if you, let's say, put your S3 bucket into VPC, it doesn't make any sense. So I will probably be able to tell as a warning to a user of Cloudcraft and say like, hey, this is not what you meant. Or you can do some other crazy things which looks cool and may impress other people, but in reality, in Terraform world or in AWS world, this doesn't make any sense. So validation and giving advices is essential, and this is something what I'm working on right now. Then if you are using Terraform AWS modules, you may think that there are a lot of them. Yeah, there are like 20 of them, or maybe more, I don't remember. But there are still not all services supported. And as previous speaker told that, yes, we don't have anything for Lambda function. There are two reasons. One is that nobody asked me to work on that. And second is nobody paid me to work on those. So pick up which is more important. Obviously, it makes sense to integrate with GitHub or with any other version control system and let code which is generated by module CF to execute on Terraform Cloud or Atlantis, or using Spacelift, or maybe keep secrets in Secret Hub, or at least execute tflint on top of the infrastructure which is generated. All of this is possible to integrate, and we'll see which one I pick up first. Many people ask, is it possible to get visual diagrams from Terraform? And the answer is yes, it is possible if everyone would be writing Terraform code in exactly the same way always. Like, don't go to Terraform documentation, don't read about any features, don't think about any crazy combinations, just use resources. Then yes, we will have it perfectly fine. It is possible to generate visual diagrams from Terraform TF state files. And I did this as a proof of concept more than a year ago, and so far I didn't prioritize it at all. Maybe I will work on this by next AWS reInvent. So if you have any other questions, please let me know on Twitter or LinkedIn or any other places. And I see a lot of questions already in chat. Somebody asked TerraHub someone have used it. Yes, I looked at it some time ago, and I know developers, but I was really not big fan of using their configuration style, and they're too opinionated in many things. So I don't see how this can be integrated in the near future unless they rewrite everything themselves. And yeah, feedback is always welcome. And I think I will see some of you, if not most of you, in real life in the near future, because I travel a lot and speak at different meetups. And I'm also blogging on antonbabenko.com about Terraform and AWS related stuff. So you're welcome there as well. There are a few other questions.
Yeah, we can do one more question, I think.
Okay. So does Cloudcraft with modules TF and Terraform can work with Ansible and automatically configure infrastructure after spin up? Everything is possible, but modules TF will not do this for you. Modules TF will take care only of infrastructure. And once infrastructure is created, then it will be a job of Ansible to do the rest. Using something like Terraform inventory, you can discover resources and then run Ansible playbook on top of them. The reason why this is not possible to make it using modules TF is because there are a lot of ways how this can be integrated, and I don't want to be so restrictive. How you're working with Terraform and Ansible? Any best practices from your side? Yeah, so I always treat infrastructure on Terraform side, and then something else is calling Ansible. You can use null resource provisioner to execute Ansible playbook, for example, from user data, or you can use Ansible just after Terraform is executed in your own pipeline. I think these two approaches are most common.